Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is binomial random variable. The binomial distribution is a discrete probability distribution of the successes in a sequence of n independent experiments. The experiments would be of the type yes or no. A specific type of discrete random variable that counts how often a particular event occurs in a fixed number of tries or trials. This is called random variables. For a variable to be normal or binomial random variable, all of the conditions must be met. Let me list out the conditions one by one. First condition is there are a fixed number of trials. A fixed sample space should be there. This is the first condition, and the second condition is on each of the trial the event of interest either occurs or does not. And third important condition is the probability of occurrence or not is same on each of the trial. Fourth condition is the trials are independent of one another. Only if all the four conditions are met, then we can call a variable as a binomial random variable. Okay, now let us see what is the mathematical notation for binomial random variable. So a binomial random variable is denoted by either p of k or p of x is equal to k, and n is nothing but the number of trials, p means the probability of success in each trial, k is nothing but number of success in n trials. Now we try to find out the probability of k success in n trials. Here the probability of success in each trial is p independent of other trials. Am I right? So first we choose k trials in which there will be a success, and in rest n minus k trials there will be failure. So the number of ways to do so is n factorial over k factorial times n minus k factorial, which is the combination of n and k. Am I right? This portion. Since all n events are independent, hence the probability of k success in n trials is equivalent to the multiplication of the probability of each trial. Let me explain this part too. Since all n events are independent, hence the probability of k success in n trials is equivalent to multiplication of the probability of each trial. Hence it's k success and n minus k failures. So probability for each way to achieve k success and n minus k failure is p raised to k times 1 minus p. 1 minus p is this failure raised to n minus k. Hence final probability is number of ways to achieve k success and n minus k failures times probability for each way to achieve k success and n minus k failure. As a formula, the binomial random variable probability is given by p of x is equal to k. Hope you are clear with this formula? Okay. Let n be a binomial random variable with the number of trials n and probability of success in each trial be p. So what would be the expected number of success? Let me give you the formula for both expected number and variance of the number of success. N times p, and variance of the number of success is given by n times p times 1 minus p. 1 minus p can also be written as q. Q denotes the failure and p denotes the success. So these are the formulas you should learn in binomial random variable topic. Okay. We will now introduce a special class of discrete random variables that are very common. Because as you'll see, they'll come up in many situations, which is nothing but binomial random variables. Okay. First, we will explain what kind of random experiments give rise to binomial random variable and how binomial random variables define in those types of experiments. And then we will present the probability distribution of binomial random variable, which will be presented as a formula. And I'll also explain why the formula makes sense. And then we will conclude this video by presenting the mean and standard deviation of the binomial random variable. Okay, as we just mentioned, we will start by describing what kind of random experiments give rise to a binomial random variable. We call this type of random experiment as binomial experiment. So let's see what is binomial experiment now. Binomial experiments are nothing but random experiments that consist of a fixed number of repeated trials. For example, if you're tossing a coin 10 times randomly choose 10 people, rolling a die 5 times. These are the examples for binomial experiments. In these trials, however, need to be independent in the sense that the outcomes in one trial has no effect on the outcome of the other trial. That is called independent, no? So in each of these repeated trials, there is one outcome that is of interest to us. We call this outcome as the success. And each of the trials is identical in the sense that the probability that the trial will end in a success is the same for each of the trials. So for example, in our experiment in tossing a coin 10 times, we are interested in the outcome head. So getting a head means success here. Then we will do the binomial experiment. Since the 10 trials are independent, the probability of success is 1 out of 2 because there are 2 outcomes in tossing a coin, head and tail, and getting a head is a success. So 1 out of 2, 1 over 2 in each of the 10 trials. Hope you are clear with this concept. Binomial experiment. So far we saw the requirements for a random experiment. I mean the conditions for a random experiment to be binomial experiment. Okay, I'll just repeat it. A fixed number of n trials should be there, and each trial must be independent of the other. Each trial has just 2 possible outcomes. For this example, generally we used to get success, or whatever you're getting other than success is failure. Am I right? The outcome of the interest is success and others are failure. There is a constant probability p. We usually denote the success by small p and failure by 1 minus p, or you can also use q. Sometimes it is denoted as q. So in binomial random experiments, the number of success in n trials is random. It can be as low as 0 if all the trials end up in failure, or as high as n if n trials end in success, all the trials end in success. The random variable x that represents the number of success in those n trials is called binomial random variable. This x I mean. Okay, and it is determined by the values of n and p. We say x is binomial with n is equal to something and p is equal to something. You will understand this concept more if we take few examples. Let us consider few random experiments. In each of them, we will decide whether the random variable is binomial or not. If it is, we will determine the value for n and p. If it is not, we will explain why not. So this is the first random experiment I have taken. So let us check whether it is binomial or not. Please read the example question. A fair coin is flipped 20 times. X represents the number of heads. So here x is binomial with n is equal to 20. And p is 1 over 2 because tossing a coin gives you 1 out of 2, which is nothing but 0.5. So here x is binomial. Let us move on to the second example. Example is you are rolling a fair die 50 times and x is the number of times you get a 6. So do you think this is binomial? We have n is equal to 50 and p is getting a 6. Okay, a number of times you get a 6. So 1 out of 6. So this is a binomial one. And third example, roll a fair die repeatedly and x is the number of rolls it takes to get a 6. Okay. By reading the question again, you can understand that the number of trials is not fixed. Am I right? X is the number of rolls it takes to get a 6. We are not sure how many trials are there. So x cannot be a binomial one here. So x is not binomial for the third example. And for the fourth question, you're drawing 3 cards at random, one after the other. Please notice that without replacement. From a set of 4 cards consisting of 1 club, 1 diamond, 1 heart and 1 spade. X is the number of diamonds selected. So you have to check whether this experiment is binomial or not. Read the question again and check. Yes, the selections are not independent, no? The probability of success is not constant because it is affected by the previous selections. Without replacement means it will definitely affect the result of the other because one of the card which is already picked is not replaced back. Am I right? So x is not binomial here. You can say that selections are not independent, therefore x is not a binomial experiment here. Hope you are clear with this example. In case if you are going to take the same example with replacement, so what would be the answer here? Whether the experiment is binomial or not? n is equal to 3 and p would be 1 out of 4. Am I right? So obviously x would be binomial in this case only if the condition is with replacement is applicable. Hope you got this idea. Okay, next example. One last example. Please read the question once. Approximately 1 in every 20 children has a certain disease. Let x be the number of children with the disease out of a random sample of 100 children. Although the children are sampled without replacement. Please notice this word without replacement. It is assumed that we are sampling from such a vast population that the selections are virtually independent. Okay. Even though this condition without replacement is present here, the outcome of one event is not disturbing the outcome of the other one. They are independent, virtually independent. Am I right? So n is equal to 100 here, 100 children, and p is 1 out of 20, which is nothing but 0.05. So x is binomial in this case. Hope you're clear with these examples. So in this video we learned the conditions for a random variable to be binomial. We saw the formula, notation and few examples and identified how to check whether the experiment is binomial or not. In case if you get any query regarding this video, you can let me know. See you in the next video.